Okay, so the question is, so you have these cards. So we have one moon card and one crown card. I'm just not going to say card anymore. One moon and one crown. And then the question is to put the cards so that the probability of getting moon is 1/4 of the probability of getting crown, right? So how many moon and how many crown do you need on the table to achieve that? So I just make it like this. The probability of getting moon is equal to 1/4 the probability of crown. And I know if it is 1/4, then I need to put 4 crown and 1 moon on the table. Then I got moon is one out of 5 cards, and the crown is 4 out of 5 cards, right? It makes sense. This equation is correct. If you cancel this out, you got 1/5 equal to 1/5. But I don't really understand why, if the question is asking to make so that the probability of the moon is equal to 1/4 the probability of crown, I need to put 1 moon and 4 crown on the table. I know to answer that I need to put 1 moon and 4 crown through pattern recognition, but I don't intuitively, logically understand why exactly. So I try to imagine that on the table I have 1 moon and 4 crown, right? So I said to myself, explain the probability of moon in terms of the probability of crown. So the probability of getting moon is 1/5, and the probability of getting crown is 4/5. So in order to get 1/5 out of 4/5, I need to multiply it with something, right? So probability of the moon in terms of the probability of the crown. So to solve this, I just need to move this 4/5 to the other side. So we flip it around. So 1/5 times 5/4, like this. So we cancel this out. We got 1/4, 1/4, and 1/4 is the answer. So the probability of getting the moon is 1/4 of the probability of getting the crown, right? So back to this, it makes sense. Probability of getting moon is equal to 1/4 of the probability of getting crown. Okay, so now at least I understand on how to get the probability, the multiplier in terms of probability of A in terms of probability of B, right? So the probability of getting moon is equal to 1/4 of the probability of getting crown. See, this is A, this is B. Okay, so let's say, so that is 1/4, right? So what if the question is put the cards so that the probability of getting circle is 2/3 of the probability of getting square, right? So now it's getting quite complicated. So I make the probability of the moon right here. We don't know how many cards there are, so we don't know over what number, equal to 2/3 of the probability of getting square. We also don't know the denominator, how many cards on the table. So I just try to guess. Let's say I put there's 3 square and 1 circle here, so we got a total of 4 cards, and then we cancel out. We got 2/4. 2/4 is 1/2. 1/2 is not 1/4, right? So this equation doesn't pan out. And then when I look back at this equation, I understand that the probability can be on the one side of the equation, and the other side of the equation is only the probability of A and the probability of B, right? So you can see here that this is the probability of A, or the first part, and this is the probability of B, or the second part. And then I recognize that the denominator doesn't really matter because it will always cancel out each other because they are related, right? So if you look at here, if there is 1/5 of this, there is 4/5 of this part 5 and 5 over here, always related back to A and B of this. So whenever we add one more this will also become 6, and this part will also become 6, right? So this 2y over here always cancel out each other. It doesn't really matter how many cards you have on the table. So I just put y there so we can cancel out. So to get the probability of circle equals to 2/3 of the probability of getting square, I just need to put the probability on one side of the equation, 2/3 equal to the number that we want to find over whatever down here. I just put y because these both two will cancel out, and then I will get the second part. So I just need to, so that's basically how you get the answer. So to get the probability of to make sure that the probability of the circle is 2/3 of the probability of the square, I just need to put 2 of the first part and 2 of the second part. So 2 of circle cards on the table and 3 square cards on the table. So now we have that. So let me draw that. Let's see, we have 2 circle and 3 squares, right? All right. So now the probability of getting a circle is 2 out of 5. It is 2/3. The probability of getting square. Square is 3 out of 5. So if we cancel this out, we get 2 over 5 is equal to 2 over 5. So yeah, so basically now we know how many number of cards we need to put on the table to get this multiplier of the probability. A times multiplier times probability of B. So yeah, that's basically it. So if we have to find the probability of circle equal to 2/3 of the probability of square, then we know that we need to put 2. The top part will be the number of circle, and the bottom part is the number of square. So let me put this into a sentence. So for example, we have probability of circle is equal to 2/3 probability of square, right? So probability of circle in terms of the probability of square. Let me do it like that, right? So probability of circle is 2/3 of the probability of square. To solve that, we need 2 of the circle, right? So the top part over here is for the first part, and the bottom part is for the second part, because this part will cancel out because they are the total number of cards that will always be same value, so they can always be cancelled out. So the top part will be the number of cards for the first part and the bottom part for the second part. So if the probability to make that probability of circle is equal to 2/3 of probability of square, you just need to put 2 circle and 3 squares on the table. And yeah, that's pretty much it. Right, thank you very much for listening, and hopefully you got a better understanding on this problem. All right, bye, have a good day. Ta-ra.